Today's video is lesson 5.5, solving quadratic equations by graphing. Our goal today will be to solve a quadratic equation by graphing to find its x-intercepts. This is the third method that we've learned in which we can solve a quadratic, and just like the completing the square method, we can use solve by graphing on any type of quadratic, whether we can factor it or not factor it. So again, we've talked about this several times, but all quadratics have two solutions. It's to the second power, so it has to have two solutions for x. But those solutions may not always be real number solutions. They may be imaginary solutions. Most of the solutions that we'll see will be real number solutions, but there may be times where we get no real solutions because they're imaginary solutions. And I'll show you what the different types look like on a graph. So here's a basic sketch of the most common type of quadratic. So most quadratics, when you graph them on a coordinate plane, will intersect the x-axis at two different places. So there's two different values for x. But there's also another type of quadratic that only intersects at one point but has two solutions, and they're both real number solutions. And what that would look like is if you graphed a quadratic that came down and just touched the x-axis at one place. So something like this. If our quadratic touches only at one place, okay, at that place it's a repeating solution. Repeating value. So it's a perfect square, so something that looks like x minus 2 squared equals y, where the value for x is 2 and it's a repeating 2. So these are both examples of real solutions, and this is what a imaginary solution will look like on a coordinate plane. So draw a coordinate plane here. So an imaginary solution is when the quadratic does not intersect the x-axis at any place. So if we had a quadratic that came down and then went right back up, and you can see that it's never going to cross the x-axis because it's above it, right? Or you may see it, come from negative infinity and then stop and then go back down to negative infinity. It does not cross the x-axis. And what that looks like in algebra, if you were to solve it using algebra, it would be when you try to take the square root of a negative number. Remember, we can't take the square root of a negative number. So if you were solving and you had to take, and you're taking the square root of a negative number, your solutions would be imaginary solutions, and another way of saying that is no real solutions. So let's get into a couple examples today. So the first example, it's asking us to solve for x, and we have the example x minus 7 squared equals 100. The first step is to convert the equation into graphing form, and what that means is you need to eliminate all of the terms on one side so that you can create a 0. Because that 0 really represents the y value. We know that the x-intercepts will have a y value of 0, so we've got to create a 0 on one of these sides. So you always want to try to choose the side that is the easiest to create the 0 on. And in this case, if we subtract 100 from this side, and we'll make sure we do it to the other side, we can create the 0 on the right side. Our new equation would be x minus 7 squared minus 100 equals 0. So now we have the equation with 0 on one side. Our second step is to use the graphing calculator to plot the equation. So I'm going to pull up the graphing calculator right now, and here we have it. So we're going to go to graphing, and then you can see here we've got our graphing options. We've got this y right here, which represents our 0. And so we can go ahead and plug in what we have. So we've got parentheses x minus 7 parentheses squared minus 100. Whoop, that's 1,000. So I typed it in correctly. Double check to make sure you typed it in, because it's going to give you different x-intercepts if you type it in incorrectly. Now we're going to go to graph. And you can see here that I've got to pull this window down a bit. It's graphed our quadratic, but we can't see the entire thing. So I'm going to use these two features, this zoom out and zoom in feature. So first I'm going to zoom out so I can get a glimpse of the quadratic. And so now I kind of can see the quadratic and where it's crossing. It's crossing at two different places on the x. Now I just have to figure out what those two places are. And we've got a scroll feature up here that the window isn't showing. Okay, and these are going to let you go side to side, but I want to zoom into one of those features, so I'm going to zoom into it. And it looks like it's crossing at, that is -3. So I'm going to write down -3 right here. I think that's probably one of my solutions. And then the second x-intercept, I'm just going to scroll over here. Looks like it's, whoops, too far. It looks like it's crossing at 17. But I'm going to make sure using the table. So now I can go to the table feature, and right here, if I plug in the x value, it's going to show me what the y value is, and I'm looking for when the y value is 0, because that's when I know I've found the right x-intercept. So right here, 17 is already in this table for us. So we see 17 and the y value is 0. So this solution is correct. And now I've just got to verify that -3 is. So I type in -3 and I hit apply. And -3 has a y value of 0. So this solution is also correct. If I put it in numeric order, -3, 17, and I am good to go. Second example. So here we have x squared equals -3x minus 3. I've got to create a 0 on one side. It's easier to create the 0 on this side because there's only one term to eliminate. So I'm going to subtract this x squared minus x squared, and then minus the x squared. Those go to 0. So we have 0 equals, and I'm going to write up here, -3x minus 3 minus x squared. Doesn't matter if it's in standard form, the calculator is going to be able to read it in pretty much any form. So I can go back to expressions. I'm going to delete what I just put in, or I'm going to reset it. Now I'm going to type in what we have. So we have -3x minus 3 minus x squared. Now I can hit graph. So now you can see that this quadratic right here is not intersecting the x-axis at any place. We have the maximum value right here where it starts to bend back, and we can see that it's never going to intersect. So because it's not intersecting, we know that it's going to have imaginary solutions, but for our case, all we have to say is that it has no real solution. And there's a cool way of abbreviating this in Schoology. Instead of having to type out no real solution, you can just type NRS, no real solution. Example number 3. So here we have -4x equals a -x squared plus 21. It makes the most sense to create the 0 on the left side since there's only one term. So we're going to add 4x. We're going to add 4x. And now what we have is 0 equals -x squared plus 21 plus 4x. And we can go ahead and graph. So I'm going to reset this. And that 0 is our y, so we can start with the -x squared, -x squared plus 21 plus 4x. And I can hit graph. So I can't see the full quadratic, so I'm going to go ahead and scroll out a bit. and it's opening down, so we've got a maximum value, but we want to focus on the solution. So if we're going to zoom into the x-intercept, and I'm zooming in, and it looks like this is -3, so it looks like one of our solutions is -3. I'm going to have to verify. And then our other solution, we're going to go to the right a little bit, and it looks like this solution here is 7. So it looks like these are our two solutions, but I'm going to verify in the table. So first I'm going to type in a -3, hit apply, and I'm looking for to make sure that the y value is 0, because that's going to be the x-intercept, and it is. So this one is checks out. Now let's check 7. And 7, 0, 7 also checks out. So we know our solution in numeric order is -3 and 7. Example number 4. Example number 4. So you can see here that our first step is already done for us. We have a 0 on the right side. So we can go ahead and put this into the graphing calculator right away. I'm going to reset this, and then -x² plus 5x. So -x² plus 5x. We're going to hit graph. And we got another quadratic that is opening down. And it looks like our x-intercepts are 0 and 5. And I'm going to verify using the table. So I'll type in 0. And when x is 0, y is 0. So our first solution is 0. And our second solution we think is 5. And it looks like our second solution is 5 because y is 0. Last example for today. Example number 5. And right now I can already tell if I was going to solve this algebraically, the first thing that I would do is take the square root of both sides, and I'm taking the square root of a negative number, so I already know that this is going to be an imaginary solution. So when we put this into the graphing calculator, I'm almost positive that it's not going to cross the x. But let's do it anyway. So we're going to add 81. That's the easier side to create the 0 on. And we've got x plus 1 squared plus 81. Reset it. X plus 1 squared plus 81. We'll hit graph. I'm going to zoom out because I can't even see anything. Keep zooming out until I can see the quadratic. And now I can't even see the quadratic anywhere. Okay, finally it took me a while to find it, but you can see that it's crossing right here when the y is 81, and so that it's never going to cross the x. So we can again say that this is no x equals or has no real solution. It has imaginary solutions, and you'll learn about that as you take Algebra 2. Good luck on the problem set.